Today, I will be talking about the basics of service mesh. I would like to introduce you to the concept of service mesh and show you how you can utilize it in your organization and when you shouldn't think about introducing service mesh. So basically, who am I to talk about service mesh? For the past year, I was working at Allegro in the team responsible for writing our own control plane and maintaining service mesh in Allegro. So starting from the beginning, maybe not this far, but from the time we started writing software, at the beginning, there was most of the software was written as monoliths. The word was simple. We had all of our functionalities inside of a single service. So we could use function calls in order to communicate between our modules or packets, which was easy, didn't cause much errors. Of course, there could be some problems with method invocation, but it's rather rare. And then the world changed. Instead of a single monolithic service, we started seeing companies adopting the microservice approach. And we couldn't any longer communicate via function calls. We had to utilize network to communicate between those services. Probably most of you are familiar with HTTP protocol. And so this was, for most of the time, this is the basic way of communicating between the services, but that's not all. Later on, there was databases, queues, other protocols like gRPC, HTTP2, introduced to the mix, and everything started to be more chaotic than previously. And we need to remember that world is not perfect. And I hope you remember the 8 fallacies of distributed computing. For you that are not familiar, I will go through them right now. So the network is reliable, latency is 0, bandwidth is infinite, network is secure, topology doesn't change, there is one administrator, and the network is homogeneous. There's a lot of people when dealing with distributed services or starting working with distributed services that think that everything will be fine. They don't experience any issues on the network and don't think about stuff like retries, circuit breaking, timeouts, etc. So we could work with this issue. We could create a library that we will be using in our services that will have these common functionalities inside of them, which will work. And most companies start from such an approach, but it's not ideal solution because some of our services might be written in Java, some in Golang and Python, Node.js, etc. And we don't want to rewrite all of those functionalities inside of those libraries and in different languages. We will be simply wasting our time. So what if we could take out those functionalities and place them in a different process and simply communicate with this process, and this process will take care of everything for us. And we can do it. And this is how the guys at Lyft were thinking about this a couple of years ago when starting Envoy project. So Envoy is basically a layer 4 proxy. It's used for communication between services. I hope that you remember the ISO-OSI layers. We start from physical first layer and go up, increasing the abstraction levels until we reach the application level. The two interesting for us layers are layer 7, in which we use TCP/UDP protocols, and the layer 7, which, for example, HTTP is placed. And besides natively operating on level 4, Envoy can be used as layer 7 proxy. Thanks to this, Envoy can understand your requests and responses and do stuff accordingly to those requests. Also, Envoy can be used as a load balancer. It exposes us to classic load balancing strategies like round robin, but also more sophisticated like maglev, which is based on consistent hashing. The one thing that stands out here is that Envoy can load balance UDP traffic, which, for example, AJ proxy cannot. Also, Envoy can be used as API gateway. There is this movement right now that Envoy will be increasing its capabilities in API gateway area. And what Envoy actually can do for you. So starting from security, our engineers don't have to worry about the securing of communication, the encryption of the communication. Envoy provides us with mutual TLS encryption. The software engineers don't have to worry about getting certificates, signing them, rotating them. It's all happening on the Envoy level. Envoy can provide us with service discovery. In the previous world, we have to, for example, in Allegro, we use console. We have to make some requests to console to get the set of live instances, pick one of them, and then make a request. In Envoy, you simply go tell Envoy that you would like to communicate with service A, for example, and it will know where are its instances, and it will route you accordingly. Envoy also provides us with active health checking. It can health check your application, and if your service or instance of service is having any troubles, it will remove it from the cluster, and the requests won't reach this dying service or this unhealthy service. Moreover, Envoy can provide us with much more observability. Besides the metrics around layer 4 communication and level 7 communication specific, for example, for HTTP, like response codes, times, request times, and etc. We can have distributed tracing built on top of Envoy. Envoy can do retries for you. In a classic world, you will have to utilize some library, for example, Resilience4j in a JVM world. In the new service mesh world, Envoy can do it for you. It will utilize the exponential backoff in order to not kill the service that you are communicating with. You can specify timeouts that will suit your needs on Envoy. Envoy can do circuit breaking for you. You can specify how much connections should be open between the services. You can use outlier detection to check if some of the instances, for example, are returning lots of errors and remove them from cluster. And Envoy will periodically check if the instance is live again, and if it came back to its previous state, the working state, it will include it again in the cluster, and we will start again communicating with it. What also can be done is rate limiting. We have basically two options: local rate limiting and global rate limiting. Local rate limiting is rate limiting per instance, per Envoy instance, and we can have global rate limiting, which could be utilized, for example, when building API gateway and charging your customers for some traffic. The other nice thing is request shadowing. Let's say you are implementing some new feature and or changing one of the existing features. You would like to test this change on the production traffic, but you don't want to break anything. So you can spin up new instance with your changes and duplicate the traffic between the live production instances and your test instance, and check if the responses from this service are the same as from the live previous version instances. And everything is working fine. You can simply introduce new version to production. But that's not all. The possibilities are limitless, basically. Envoy is highly customizable and extensible with Lua filters and WebAssembly filters. You can write your own filters and where you can operate on, for example, layer 7 request responses and do really interesting stuff with this. So going back to our envoys and our data plane, we have to somehow configure those envoys. So how do we do it? We basically have two options. With the static configuration, we will be creating files with the configuration that that contains all of our all the things we would like to configure, like timeouts, retries, and etc. It's easy. We create simple file, but if we like to change anything, there the problems begin, because we would have to restart this Envoy. It provide the new file, and it's becoming tedious. So in the most of the use cases, we are using control plane to configure our envoys, and we do it dynamically. And how does the control plane work? So basically, it operates on two data sources. The discovery, for example, in Allegro, we are using console, so we are getting the state of services from console, their instances, where they are placed, and other stuff like console tags, which tells us how we should load balance traffic between those instances and other stuff. And the second source of configuration is user config, where people or the owners of services specify things like timeouts, retries, and possible, and for example, dependencies that they will be using. And our control plane takes all of those sources of data and combine them in a single state, and send this state to the envoys that need those kind of informations via the XDS protocol. It's a Discovery Service Protocol that was created in Envoy team. So going to the examples of control planes, we have Istio, which is basically one of the first service meshes built on top of Envoy, control planes built on top of Envoy. It's big, it provides us lots of possibilities, but because of this, it's sometimes hard to grasp all of this and configure it properly. Then we have another open source project, Kuma. Kuma started with the assumption that not all of the companies are using only Kubernetes, that there is also the virtual machines world and other runtimes like Nomad or Mesos Marathon. The next one is Linkerd. Linkerd is interesting because it's not using Envoy as a data plane. It's implementing its own sidecar. And going further to the smaller project, we have Console Connect, which is built on top of console. And if you are using console in your organization, probably it will be easier to simply use Console Connect as a service mesh, because it will be easily integrated with your console. And there is Envoy Control, which is a product built in Allegro, and it's also open source, like the rest of those solutions. And there's the question why we created our own control plane. So the couple of years ago, when Service Mesh project started in Allegro, basically there was one or two options, Istio and maybe Linkerd, but all of those options were strictly bind with Kubernetes. And in Allegro, we are in the process of migrating to Kubernetes right now, but a couple of years ago, we were using only Mesos Marathon and virtual machines. So we wanted to combine all of those two worlds and provide our users with the functionalities of Service Mesh. And that's why this project was created. So you see now what Service Mesh can give you and how you could utilize it, but it all comes with a price. As always, you cannot simply spin up a control plane instance as a sidecar and everything will be fine. You need to remember that platform complexity grows when you're introducing Service Mesh in your organization. You are moving the common code from the service to the infrastructure level, but the complexity is never gone. You always have to deal with the complexity. Previously, every team had to work with this complexity in their services. Right now, you could work with this complexity on the infrastructure level with dedicated teams that are specialists in the topic. And you need to remember that Service Mesh is good for major platform, because for sure you will have to have a special team that will be responsible for updating new versions of Service Mesh, combining it with your current organization, educating people about how to use Service Mesh, how they can utilize it. So it's always, you always have to hire the people that will take care of this complexity. We need to remember that because it's Envoy is a sidecar and it's another process that is running alongside our service, we will be increasing resources usage because all of the traffic has to go through our proxy. And for example, in the specific cases, like in Allegro, we have this Edge server, which is our API gateway for our customers. The resource usage of Envoy is almost the same as our API gateway. So you need to remember that you will have to allocate more resources for your Service Mesh. Also, you need to remember about troubleshooting. Envoy gives you a lot of new observability tools. You can see what's going on the connections on the HTTP level. You can use distributed tracing. You can use one of the newest Envoy functionalities to gather TCP dumps from Envoy. But you have to remember that it's not all. You need to create other options of observability in order to make sure that you see what's going on the lower levels of infrastructure, on the network. And previously you were looking for problems inside of your code, inside of your services. Right now, it's Service Mesh and Envoy. You have to look for those errors somewhere else, probably not in your code base, and this could be troublesome sometimes. Okay, so we basically know right now the basics of the Service Mesh, and we can look where this world is going on right now, what is changing, and what are the future ideas for the Service Mesh. So Service Mesh is getting more boring every day, which is nice because we want networking to be boring. We want service mesh to be boring. We don't want to spend lots of time dealing with configuration, adapting service mesh to our platform. We would like it to, in the best scenario, you would simply run it and forget it's doing stuff. The other interesting thing is sidecarless service mesh. So one of the top companies that are working right now on this project is Cilium. They are working on a sidecarless service mesh. So basically, previously, when accepting requests, the data would have to go back and forth from the network card to kernel to Envoy, back again through the network stack to our application. And Cilium is utilizing the eBPF. eBPF is extended Berkeley packet filters, which lets you write code that is executed in the kernel level on events that happen. For example, event in our situation could be receiving data on socket. So you can basically connect to sockets and move them and move data between those sockets without going back and forth inside of kernel, which is really interesting. But I'm afraid that when you have lots of services, you will be having troubles configuring those envoys in order to them to be able to work on all of those work with all of those services. So another interesting topic is zero config, which Linkerd is working on right now. So basically, they say that you can install Linkerd on Kubernetes and forget you have service mesh. It will dynamically check what type of protocols you are using and adjust configuration accordingly to the protocols you are using. For example, you are using HTTP, it will read first few bytes of the request, checking what protocol you are using, in which version, and configure itself accordingly. So it all looks nice. We see that service mesh is evolving. It has bright future ahead of us. So how do you actually convince your team, your business to utilize service mesh? Because it's always hard to introduce new technologies and especially the technology that will utilize more resources. You will have to create a team responsible for deploying and handling of the service mesh. So how the biggest selling point for me is that thanks to service mesh, you are making the networking as boring as possible, because previously developers had to deal with retries, circuit breakers, and right now all of those functionalities can be created and configured on Envoy, and good defaults across the organization can really make wonder. And for the most common cases, people won't even notice that there were some retries or the instances were removed from the clusters that circuit breaker started. And so thanks to this, the engineers in your organization that are working on business code don't have to deal with the complexity of the network, of infrastructure. They simply can focus on writing business code that will give you advantage on the market, and you will have to hire less engineers in order to provide your business with the same functionalities. And the one thing is that thanks to service mesh, we can have easier global changes on our organization scale, because we are changing infrastructure, and infrastructure for our teams should be invisible, and they shouldn't be worried about the infrastructure. So for example, if we are trying to introduce distributed tracing, previously you have to create a functionality for propagating headers to the services that are downstream to your service. And right now you simply enable new functionality of Envoy, restart all of the envoys, and you are good to go. You have migrated whole organization without people even noticing that you introduced something new. So key takeaways from my presentation, as I'm moving toward the end of it. I would like you to remember that service mesh is about moving common code from service to infrastructure level. And service mesh can provide you with increased observability and resilience. And service mesh should make networking boring. You shouldn't deal with retries, timeouts, and circuit breaking. Yeah, but all comes with a price, and you will have to pay the price when introducing service mesh in your organization. But hopefully, in most cases, the advantages of service mesh will be much bigger than the price you'll have to pay. And in the future, we will see more of the more and more adoption of service mesh solution in the bigger organization. So that's all for me.
Okay, I think I saw a question for Marcin, but it's not there. I think the question was, which is the hardest protocol to be proxied? Something like this.
Okay, so basically, because Envoy natively runs on layer 4, you don't have to worry which you are proxying, which protocol you are proxying. If you don't want to get into the requests and the payloads of the and inside of the traffic, because basically TCP and UDP are familiar, and you're operating on a pretty low level, so you don't. There's not much difference between the protocols.
Okay. I don't see next question, but I will have a question for you. What did you learn building a control plane in Allegro?
Okay, so I wasn't from the start of this project working on this, but throughout this year I learned a lot of networking. I learned a lot of how Envoy is working, what can you use it for, how we utilize it, and basically I expanded my knowledge in distributed computing, and yeah, that's the things that I learned during this year.
So my next question is based on your slides. I see that the service mesh movement is getting to our homes, I would say, through zero configuration or another features that will reduce the cost of introducing the service mesh to the companies. How do you think will service mesh will be prevalent or be used in most of the companies in few years, or will it be technology for big companies only?
Okay, so for sure, there is there are two worlds. The world that is basically using only Kubernetes, and all of their the infrastructure and services are built on top of Kubernetes.
Yeah.
And for those companies, the introduction of service mesh will be much easier than for the rest of the companies. But I think that most of the world, it's not only Kubernetes. There are a lot of companies that didn't start like a few years ago and adopted Kubernetes from the beginning. There are a lot of companies that are using still operating on virtual machines, like here in Allegro. So unless the bigger players like Istio and Linkerd fully adopt the virtual machines, there won't be much movement in the area. But hopefully, as I said, I believe that service mesh will be getting more boring with time, and it will be easier to introduce it to your organization. And for sure, there will be more organization that will be using Kubernetes, and thanks to this, the adoption will be higher.
Yeah.
But for sure, it will take time, and a lot of talking with the organization about introducing such a technology. But also we see that a lot of bigger players like Google are working on fully managed control planes. So you wouldn't have to worry about managing your own control plane. When using Google Kubernetes engine, you will be able to spin up Istio and use Istio that is managed by Google. So it will be even easier to adopt service mesh in the future.
Yeah, it sounds tempting. Okay, we have a question. I can read it to you. What is the scale use case that you think is worth investing in service mesh? That's the first question.
So basically, I see, after talking with a few people recently from different companies, I see that for most of the time, the companies are adopting service mesh because of the ease of introducing encrypted communication between the services, which looks nice from the security team perspective, especially when you are a public company and have to go through audits regularly. Yeah. You can show that your traffic between the services is fully encrypted. Which is nice use case, but you have to remember that it's not all the service mesh will give you. And when you start seeing that you are repeating yourself, you have to rewrite the same functionality on that is related to communication between the services. You see that you cannot use, for example, native Kubernetes mechanism. Maybe service mesh is for you, but be cautious about it, because once you hop on this train, it will be hard to later on get rid of service mesh.
I imagine that it's not easy to get rid of it, and especially when our infrastructure is combined with it. And regardless of the size of your company, I guess the moment in time of the life of the company it's important, because starting with service mesh might be useful, but it will be costly, and it can and will delay some features.
Yeah, and at the beginning you shouldn't worry about the infrastructure, about scaling and etc. You should be worrying about how to give value to your customers as soon as possible. So for most of the smaller companies, startup, for sure you won't be won't be investing in service mesh because you have better things to invest in, and in order to provide your users with the functionalities they need actually right now. And later on, when your organization grows, you start to develop some platform teams inside of your organization that will provide the platform for your engineers. You can start thinking about the service mesh and the benefits of using it.
Yeah. Okay, so the next question, I guess it's partially answered, but maybe you can add to it. So the question is, are there any auto-managed cloud solutions for service mesh in AWS or GCP?
Yes, so basically it's happening right now. Google is working on managed Istio. I think that the company, I'm not sure right now, but I think that also Kong with Kuma is starting to work on a similar solution. Yeah, so this movement is getting traction, and for sure there will be other possibilities to use fully managed service mesh in the future.
Okay, so I guess that's all questions for us. I'll give another few seconds for a last question, but if you don't have any questions for Marcin, then thank you all for attending this meeting. Thank you, Marcin, for preparing slides for us and for sharing your knowledge, and have a nice weekend.
Yeah, thank you. Thanks for the opportunity to be here and talk with you guys.